Hello everybody, welcome back to part B of our revision video. Starting at topic 9 in that little booklet I put online. Yeah, look, there's a couple of things in here that I feel that we need to do a little bit more work on. Histograms, I think we did once, right? And I don't know, could very well come up histograms. So I'll do a little bit the day before, but I might do a separate video. Same for some of the finance stuff like APR and AER. We've done a couple of questions, but I just want to expand on them. So when we get to them, I might miss those out and do a third video of things that I feel we've covered, but we could do with a little bit more coverage of, just in case, they come up. So let's have a look at pie charts first of all here, though, okay? Again, I'm not overly confident on pie charts. I'm just going to mention it, okay? However, if the pie chart is drawn, okay, and it's a calculator paper if we end up doing this. So just look for the number of people and then the fraction. There's not a lot more they can ask, okay? So this question was how many people chose broccoli. Now, I'm really sorry to say I haven't got a protractor on me and it's on my screen, but I need to measure that, okay? I don't even know what to guess, but let's say it's 30. I know 30 degrees, right? Out of 360, there's the fraction times how many, the total, So in this case, it's 1,080 in that diagram. Boom, into your calculator, there you are, right? Because we've got calculators, they could be nasty fractions, couldn't they? It doesn't need to be a half or a quarter or something like that. That question, how many more chose carrots than chose sprouts? Well, you'd have to work out how many chose carrots using the same method, how many chose sprouts using the same method, and then take them away. Okay, in this one, we got 720 students. How many chose individual sports? Oh, that's okay, right? Again, though, because you've got a calculator, by all means do it as that, like we said above, or in the end, it's simplified. It's just a quarter, isn't it, of 720? So half it again. Again, not useful if I had a protractor. This one says Carwyn plans to split team sports. He wants to split this up, this little section here, into football and then other. Right? Of the students who selected, of all these people who selected team sports, 2/5 said that their preferred team sport was football. What angle should Carwyn use to represent football? Well, what we're going to need to know is we're going to need to measure that angle. Again, you're going to have to be good, pretty reasonable with measuring that angle, okay? And we just want 2/5 of that angle. Again, it's okay. Again, chaps, I would say, I'll divide by the bottom times but you got a calculator, so you can just put 2/5 times, right? So there's no need there. And then the final one, I think it's just a little percentage one. 720 students took part in the survey. Only 45% were female. How many males? Well, just 55%. Now, chaps, what I will mention here, because we haven't talked a lot about percentages, and we're bound to get some percentage stuff, is in a calculator paper, we may be best writing the percentage that we want. In this case, the 55% that are male, we may be best writing it as a decimal and just times in that by the number, so 720 times 55%, or times 0.55 in this case. Okay? Right. Volume, mass, density. Okay, so earlier on we talked about population density, but more particularly here we're talking about, let me zoom out a little bit. Can I? Don't know if I can. No. We'll just scroll back and forth. We're talking about, the formula, right? I should have written it as density, mass, volume, because it's confusing me writing volume, mass, because it's density, mass, volume, like that. Okay, so just remember that. So any questions that talk about mass or density, volume, we might have to calculate the volume, I don't know, of an object. Okay, we'll talk about that in a second. So Owen has a cycle frame made from aluminium. His cycle frame has a mass of this. Calculate the volume of aluminium in Owen's cycle frame. So we want the volume. Let's have a little look again. Density, mass, volume. So for volume, it's mass over density. Now, because we're calculating the volume, it's mass over density, right? The mass, we're told, is 9,450 grams per centimetre cubed. Doesn't matter really about the unit there, as long as our units tie together. Divided by the density, well, we're using aluminium, so the density of aluminium is 2.7. Sorry, why have I put per centimetre cubed there? This is what the density is, grams per centimetre cubed, right? And if we divide those, let me get my calculator. 9,450 divided by 2.7 means that we are looking at 3,500 centimetre cubed for that one. Okay, keep going. Bethan has a cycle frame that is identical to Owen's cycle frame. However, her cycle frame is made from carbon fibre. Calculate the mass of this frame. Right? Okay, well, if they're identical, then they must have the same volume, which we've just worked out to be 3,500 centimetres cubed. The difference being that this one is going to be made out of, can't remember, what did they say? Out of carbon fibre. Fab. Let me go up and get that number quickly. So the density of carbon fibre is 1.6. So density, I'll just put D, 1.6 grams per centimetre cubed. And we want the mass. Again, let me remind myself, density, mass, volume. Okay, mass is density times volume, or in this case, 1.6 times 3,500. And the answer will be in grams. And it wants it in grams, right? However, the reason it's in grams is because the density is in grams per centimetre cubed. If it did say give your answer in kilograms, to change that to kilograms, we'd divide by 1,000. And we mentioned this earlier. If it said give your answer in tons, you divide by 1,000 again. Okay, so 1,000 grams in a kilogram, 1,000 kilograms is a ton, as a reminder. But in that question, we wouldn't need to do that. What else we got? We've got another one of these. I'm not going to do a very similar sort of thing. Okay. All I will say here is this. Area, thickness of the skateboard. So what we are looking at here, and I know it's probably not, oh dear me, this shape, but what we have got here, bad 3D drawing that, isn't it? Is this is the area of the deck, and then it also has depth or thickness. So to get the volume, we're going to have to times the area by the depth. Remember, if we have to calculate the volume, we need to get the area of the top surface or the front surface and times it by the depth of the shape. So this question says, how much heavier is Finbar's skateboard than Sab's skateboard? So once we've worked out the volume and we know that it's fiberglass, for example, if we were doing Finbar's skateboard, its volume would be 1,800 times 1.2. Okay, once we know the volume, we also know that it's made of fiberglass, which has a density of 2.6 grams per centimetre cubed, and we are being asked for the mass. And to get the mass, it's the volume times the density. So whatever your answer to this is, times this. You do the same for Sab, and then work out, but using Maplewood, and work out who has the heavier skateboard. Lovely. Okay, bit of ratio in here as well. Lovely. We might get a bit of ratio somewhere in any question hidden in. Okay, a solid statue is made from an alloy of copper and tin. It has a volume of 150 centimeters cubed. So some of that is copper, some is tin. In the statue, the volume of copper and the volume of tin are in the ratio 22 to 3. Okay, so 22, let me just for my own sake, copper to 3 tin. Okay. Then we've got the density of the copper and the density of the tin. Calculate the mass of the statue. Well, what we need to do here is work out of that volume, how much is copper, how much is tin, right? So, again, If we're sharing in a ratio, remember, we add these, right? There are 25 parts to this ratio in total. We're splitting that 150 into 25 parts. Like so far I can do this without the calculator, which is 6 centimeters cubed in this case per part. And multiply. Add, divide, and multiply is what Adam stands for. Add the ratio, split the big number into that many parts, and multiply. Now, but when we're multiplying, what are we actually doing? Well, what we're saying is the amount of copper is 22 times 6, which is 132, and the amount of tin is 3 times 6, which is 18, and in total that makes 150, so that kind of backs that up. So that's the volume of copper and the volume of tin. We then have the density of copper and the density of tin, and we're trying to look at the mass. Again, mass, let me remind myself, dmv, okay, mass is density times volume. Right, so with the copper, we need to times that by a density of 8.96, which is here. And the tin, we times that by a density of 7.31 here. And we work out the mass of each one. And then we need the total mass by adding those together. Again, I don't need to put that in a calculator. That's just wasting your time. You can do that. So just remind yourselves on ratios as well as those. Okay, I am going to leave APR and AER and come back to it in a separate video, as promised. Let me see how long I have to I always remind myself, that I get 15-minute segments to do this. So I've got about 3 minutes left in this one. So APR and AER is going to go into a new video, if possible. Some beautiful APR and AER stuff coming up that we can do in a minute. So scrolling all the way past that, I'll explain the difference between those two, right? And we're just going to come back to arc length. Now, sector area was in paper 1, right? It was like the area of the kind of crust, wasn't it? That if I remember rightly. Okay. Arc length, though, hasn't come up, so we just be prepared that this could still come up. So the arc length, the length of an arc, is equal to theta over 360, okay, times the circumference of the circle. But to get the circumference, it's pi times the diameter. So if I was doing this one, and I was imagining this to be a full circle, okay, I would do pi times not 12, because 12 is the radius. I would double it, pi times the diameter, and I would work that out. Then I would take that answer and times it by 60 over 360. No need to simplify in paper 2 because you've got a calculator. Just stick it in. So whatever that answer is times that, and that will give you the length of this arc. If it asked for the perimeter, chaps, not only would you want this answer here, right? But if you think about a little person going for a little walk around here, we talked about perimeter earlier, that little person then would need to come back along here and back up here. So we'd need to walk that plus another 12, plus another 12. So length of the sector, just this answer here. But if it says perimeter, remember to add on the other bits that make it all the way around the shape. Okay, we're going to have a little, well, not a little break. It won't be a break for you, but it is a break for me while I restart my 15-minute video timer. It was a bit of a bump back after a little bit there, or you missed some words or whatever of what I was saying. Okay, there's one with perimeter, look. Okay, so for this one, okay, again, these are too easy, right? You've got to get this in a context. I'm teaching a lot of the stuff that I'm doing here is just the skills you need, and you've just got to work out how we're going to use them in context and stuff, right? But let's at least get the skill made out. So pi times 12 would be the circumference of the circle. Yeah, taking the radius, doubling it, pi times the diameter. Okay, then because I want just this fraction of the circle here, the fraction that I want is theta, or in this case 82 over 360. I could work that out. Do it in 2 bits if you want. Work at the circumference first, then times it by the angle. But don't forget this time to add 6 and add 6, because my little person, not only do they need to walk over to here, they then need to walk down here, which is 6, and back to where they started. So the perimeter is all the way around. And answer 2 decimal places there. Okay, nothing to say there. I should have put harder ones in this. If not, I'm going to go and find one for video part 3. Working backwards. Lovely. Let's take a look at working backwards. Okay. Here, we're told the arc length is 4.4. Okay. So, that is the answer. So we need to write this in full. We need to be able to write pi times 12 times, don't know this time, but I do have an answer. Okay. Good news, you can do this in any order you want, right? I suggest you work, again, remember calculator paper, so pi, we don't leave things into pi, we've got to chuck pi into our calculator. I suggest we work that out, right? Let's do it. I won't use the pi button, I'll use 3.14 times 12. This is not how I would set out your answers, okay, but I'm going to just do it for now. I'm just going to write it there, 37.68. Okay, to leave theta on its own, I need to take that answer, 4.4. The opposite of dividing by 360 is times 360. Then the opposite of times in 37.68 is to divide by 37.68. And I've done that in one step, right? So we will go 4.4 times, good news, you can do those in either order as well. So if you did take the times 37.68 over first and done that first there, it won't matter. When you're multiplying and dividing, it doesn't matter what order you do them in, you're going to get the same answer. Okay, so we get the answer there, that the angle is 42 degrees. Does it say to 1? Even if it was to 1 decimal place, it's 42 to 2 decimal places, it would be 42.04. Again, that's why we do a little bit of rounding. Okay, so that's like a working backwards question. You could be working backwards to find the diameter, or you could be working backwards to find the angle. Don't mind those at all. Right, what we got next on our magical, yay, proportionality. Here we go. Okay. Right, on a building site, I really hope one of these comes up because I think we can do it, right? So we're going to list the 3 things: workers, work, and job. Yeah? No, workers, work, and time being mainly, right? So the workers here are bricklayers. The work is 2,000 bricks, and the time is 8 hours. I would list, so I would go, in this case, bricklayers, bricks, and time. And we will always be given a complete sentence to begin with. 4 bricklayers lay 2,000 bricks in 8 hours. You can write your hours. You know, we could put our units there, bricks. Well, the unit for bricks is bricks. Okay. Then we're given sort of an incomplete row. To complete the work on time, bricklayers will need to lay 9,000 bricks in 10 hours. How many bricklayers do we need to do that? Okay. We need to look at the 2 things that have changed. And we need to decide what effect that change will have on the number of bricklayers. All right. In order to do it in a faster time, I would need more bricklayers. In order to put more bricks down, I would need more bricklayers. In order to put less bricks down, I need less bricks. So let's have a look. Right. So the bricks have gone up from 2,000 to 9,000. In order to achieve that, I am going to need more bricklayers, right? So the effect of that going up is that the number of bricklayers also needs to go up. However, whoever has given my company this job has said, don't worry about doing it in 8 hours, have 10 hours, a bit more relaxed. You can have a little bit longer to do it. So the result of the time going up doesn't mean I need more bricklayers. Actually, because I've got more time, I can get away with less bricklayers. Okay, so more bricks, more bricklayers, more time, less bricklayers. So the sum that I need to do, and this is the way I showed you in class, is for this number here times, and we write this as a fraction. Now, because we want this fraction to increase the bricklayers, we put the bigger number on top, times, but because we want this fraction to reduce the time, we'll put the smaller of the two numbers on top. Okay, equals, and then we get our, right, let me show you. I will do one here. I'm going to move it over here. So we've got, because again, there's different ways to put this in. 4 times, a lot of you like that button. Yeah, that's cool. Don't worry about that. By the way, if that button doesn't come up like that, okay, if when you press that button, it doesn't give you that, it gives you a weird like R shape or whatever, again, just click mode, right, 1. So these are the setup of the calculator. Now, this has nothing to do with the exam. Mode, you always want it on mode 1. And when you press shift mode, I said earlier, make sure it's on 3, but also shift mode on 1 as well. Okay, so the 3 settings are shift mode 1, maths, shift mode 3, degrees, but mode, and then but without that, just mode 1 comp as well. And that should give you that, right? So let's do that again. 4 times 9,000 down 2,000. Click across because we need to get over, because we're going to put a times there now. And the same again, 8 over 10 equals, right. So we need 14.4 bricklayers. Oh, kind of 0.4 of a bricklayer, yeah? So how many bricklayers are we going to need? Well, 14 won't get the job done. So actually, this is one of those cases, even though 14.4 would round down to 14, we got to get this job complete. So to get it done, we're going to need 15 bricklayers to do it in the time that we need, okay? Let's try one. You can try that one, right? Don't be afraid to... Okay, this time we've got engines, gallons of water, just call it water if you want, and again, time. But this time it looks like the time is in minutes. So there's my 3 things. So it was recorded that 5 engines were able to pump 26,000 gallons of water in 3 minutes. Show that 9 engines would be able to pump 143,000 gallons of water in under 9 minutes. Right, we need to show that that there is under that. So it's not saying that's the time, right? I think that's like confusing putting that there, because that looks like that's a number you can use, but it's not. We're trying to prove that our answer is under that. We need to find the answer and prove it's under that. Okay, so more engines. They're giving me more engines. Think now, think. We're looking at this time we're looking at the impact on time. Time is the missing one. I have more engines. Is that, if I've got more engines, will that increase the time for the job or decrease the time for the job? Hopefully you said, well, more engines, you can get the job done quicker. Yeah, there's more engines, so more water being pumped. Boof, brilliant. Okay, so that should bring the time down. Now, a bit of a rule here, chaps. If one of them's down, the other one tends to be up. But let's just check it. It's unusual that you normally get one of each. Water. I need to pump a lot more water. 26,000 to 143. Change a job. If you want me to pump more water, don't worry about the engines now. That's a site, right? More water is going to need more engines. So the effect of more water is more engines. So again, we start with a number, then we look at this, right? The effect of more engines bringing the time down. So we'll put the littler number on top, okay? The effect of more water takes the time up. So in this one, we better put the bigger number on top. Into your calculators we go. I am going to do it because I'm interested how we show us with less than. So 3 times. It's boring just watching me do a calculator, isn't it? Across times 143,000. I forgot to press that button, but it should still work. Yeah, 26 equals. Right. I do that. The sneaky in there, 9.17 rounded it was, okay? And people are going to say, oh, but that's 9.17, that's more than 9 minutes 15. It's not, right? Another useful thing for this is this, okay? 0.17, or actually it was 0.16666 if you round, of an hour. If you times that by 60, so if we take that, right, that 0.1, whatever it was, and we times it by 60, this is how many minutes that is. It's 10. It's 10 minutes, right? So actually, this is 9 hours, 10 minutes, which is under that. Okay, so just don't forget that, you've got a calculator now. Don't forget that an hour is out of 60. So if they say 0.37, that is not 37 minutes. You'd have to times that by 60 to work out how many minutes it is. Yeah. If it's 0.25, well, we know that one, that's not 25 minutes. If you times that, we know that's going to be 15 minutes. It's a quarter of an hour. So just, you've got a calculator, anything to do with working with minutes and hours, use your calculator, times by 60. Yeah. Okay, there might even be another one of these somewhere. Yeah, go on, over to you, right? Okay. What's next in this? Volume and surface area. Let's have a look at this one. A company makes a chicken run in the shape of a triangular prism, as shown below. The uniform cross section of the chicken run is an isosceles triangle. The run covers a rectangular ground area of 5.46. The vertical height of the run is 1.5. Okay, I haven't got a question yet, but everything I've been given is on there. Each face of the chicken run is to be covered in wired mesh apart from the base. Okay. Calculate the cost of the wire mesh that is needed for the chicken run. Don't mind if I do. Okay. Lots of work. So surface area. So we are told, let's have a look. Right, there is a missing number, I mean. We are told that the bottom, the rectangle at the bottom, all right, I'm drawing my rectangle like that, but that's the bottom surface here, has a length of 4.2 meters, but an area of 5.46 meters squared. That should allow me to divide those 5.46 divided by 4.2, which will tell me, let's have a look, 5.46 divided by 4.2, that is 1.3. Okay, where are we to go? Let's go. So the front triangle, again, my workings are going to be all over the place, okay, is a triangle with base 1.3, height 1.5 divided by 2. Base times height divided by 2. I can work that out. Boom. Happy? That's the front. The back will also be the same. Let's work it out. 1.3 times 1.5 equals divided by 2 equals, I could have done it with a little fraction thing, but we've got naught. At the moment, I'm tempted to not round that, if that's okay, right? The back would be the same, 0.975. Right, now. Okay. There's another little bump there, but I've also realised something. The whole time I've been recording the window only, right? So you've only been able to see this. And I've been using a calculator on a separate screen that clearly isn't on the video. So every time I've talked about calculators, you probably thought, I can't even see the calculator. Here's the calculator that I've been using, right? I am so sorry. That is ridiculous of me. However, what I did mention earlier, I'll bring this back up, even though we're in the middle of this question, okay? I talked about modes and shifts earlier and stuff like that. What you need is mode 1, comp, shift mode 1, maths, shift mode 3, degrees. That means that when you press this button here, this fraction button, that you'll see it that way, and everything else should be fine, right? Oh, the rest of that video, what I've been playing on this calculator, it's been a complete waste of time, but I'm plodding on. I'm not re-recording because of timing issues. Okay, so I'm sorry. Right, chaps. We had a bit of a bump there, but basically we said, look, we're going to need this. We're going to need this, right? If you think, okay, to get that, the only way we've got here is Pythagoras' theorem. If we split that, we're told it's isosceles, so we know it cuts it in half. We know that's 1.5. That's not 1.3 here, it's half of 1.3, which is 0.65. Okay, we can use square, add square root. Yeah, square, add them together, whatever the answer is, square root it, right? Once we know this, we can do length times width, and reminder that there are two of them. Yeah, let's do it just quickly because I've spent long enough on this question now. So 1.5 squared plus 0 square, add, and then square root that answer. All right, so that's 1 point. I don't mind this to one decimal place, 1.6, because the rest of the 1.6 is fine. So this here, which I'll now do down here because I'm just jumping all over the place, would be 1.6 times 4.2, right? 1.6 times 4.2, which is what? 6.72, lovely. Don't mind if I do. Again, double it because that's one of the sides, and then the other side is also 6.72. And now we need to add our four areas together. The front, the back, the side, and the other side need to be all added together to get the total surface area. This area, right? And then we're told that it's £5.60 per metre squared. So this answer will be in metres squared, and we need to times that then by £5.60 to get the cost of the meshing. Wow, what an epic. I'm sorry about the calculator thing. That's completely, yeah. I don't know what else to say. What does this one? The volume, calculate the length of the step. Okay. Again, chaps, let's remind ourselves. I just need to see that volume number. We need to keep reminding ourselves that the volume is the area of the, whatever you call it. In the front of the formation, they call it the cross section. I either call it the top or the front, right? But let's use cross section. The area of the cross section times the depth. In this case, that's the depth, and the front is this bit. So let's work out the area of the front by splitting this up. Right? Okay. This part, we'll call it A. A. The area of A is 50 times 20. It's 1,000 centimeters squared. Let's now look at B. The area of B is 25 times, I don't know how that dimension there that I'm trying to scribble there, but I do know that it's 50 from there to there, but only 24 from there to there. So 50, take away that 24, leaves me with 26. You can see the calculator now. Look, 25 times 26 equals 650. Total, sorry if you can hear people in the background, 1,650 centimeters squared. If I wanted then to get the volume, it would be equal to 1,650 times what they're calling the length, but I call the depth. However, the answer, the volume, is given to me. It's one of those where we're working backwards because we're given the answer. So we need to divide that by that to get the depth. So 66,000 divided by 1,650 equals 40. Stunning. Right, next question is, or next topic, what are we on to? Oh, chaps, okay. Seeing as we're here, right, and we're talking about volume, right, at the moment we've done things like, right, we've done prisms like triangular prisms, etc. So remember that the volume is equal to the area times the depth, just to write a point. If the area, it's a triangular prism, that area will be base times height divided by 2. If it's a cuboid, it would just be length times width times depth, right? But if it's a cylinder, a la this thing here, then it would be pi times the radius squared, or pi r squared, then times the depth. So if I was working out the volume of this cylinder here, I'd be doing pi times the radius squared, which is half of that, 6, okay? Then times the depth of 9, okay? Let's do that quickly. 3.14 times 3 squared times 9 equals 254. I've forgotten. 0.34. 0.34. Fab. Let's actually read this question. I haven't done it. I hope it's something to do with that, right? Calculate the volume. Oh, it says give your answer in terms of pi, but oh, you're joking. What have I done there? All the way back. We're getting on to one of my favourite things in a minute. Look at this. What a mess. What a great video, eh? Let's find where I was. Sorry, everybody. Can't be that far back, is it? Hey, okay. Yeah, it says calculate the total volume answer in terms of pi. Don't worry about it. In terms of pi, we're not bothering. Like I wouldn't have put pi in there, but this was obviously from a non-calculator. Then you want the volume of a sphere, but bearing in mind what we've actually got here is a hemisphere, so we need to divide that by 2. Now, chaps, for spheres and cones, your formulas are in the formula sheet. I don't have it in front of me, so I'm not going to bother looking. But I'd be finding the volume of a sphere. I'd be putting in that number as I need to, etc., right? And then I'd be working that out, but reminding myself to half my answer, because we got half a sphere, and adding that on. Let's have a little look. Chaps, can we close this door here? That's my family coming in. Because someone would come and close the door, so you can't hear them. Right, okay. Hang on, guys. I'm just going to leave this video. Sorry. Close the door. Right. There we go. I'm back. The joys. Right. There were 6 2-pence coins in circulation. A bit of standard form here. Calculate the value of these 2-pence coins. The value of them. Well, there are that many of them, and each one of them is worth 2 pence. So I need to times that by 2 pence. I do. So it's 655. I'm not even times 2. Save ourselves time here. So it's 1310 plus all these other ones. Right. Where's my? So it's boom, boom, boom. Okay. Put your answer in standard form. 1.31 times 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And show all your work. Well, yeah, just do a better job than that, right? But the reason this is made into this section with standard form is we're talking about cylinder again, chaps. So that's the diameter, but I'd need to be doing pi times the radius squared, so half of that times the depth. Again, they've used a different word again for the depth. They've used thickness again, right, as depth. Fab. Histograms next. Yep, this is the other one I'm leaving out because I'm going to do a separate video on APR, AER, and histograms. So we're scrolling past. That's going to come tomorrow. Right, and we end with this. Or maybe not end, but nearly end with this, maybe. Okay. Sine and cosine rules. So what we need to remember here, lovely people, is the 3 rules, right? 3 in particular, right? if you're going to use the cosine rule to find a missing length, you will need to know the triplet, this one, and this one, right? And if that is the case, you will call this little a, and this therefore becomes capital A, that angle, and the other two sides become B and C, and we'll use a squared equals blah, 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 blah. Again, use the blah, 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 right? The alternative rules are the sine rule, and for the sine rule, you're going to need a complete pair. For example, you would need to know both those things. You'd need to know the size of the angle and the opposite thing. That will then allow you to work out a missing angle using an incomplete pair, or a missing side using an incomplete pair. Okay, so let's go through these, keeping on looking, okay, at whether we're likely to use the sine rule or the cosine rule. Let's start here. Again, I could do with zooming out, really, couldn't I? Not a drawing. See if I can zoom out a bit. Hurrah. Okay, use Morgan's diagram to calculate the length of drainage pipe needed for house 1 and then the length of draining pipe needed for house 2. Not a problem. Let's have a little look at this. Let's go back to my my red pen. Right, okay. So we're going to start with the length of drainage pipe for house 1. It's been very kind to us and told us which one first, okay. Looking at the two triangles, I know 1, 2 things on this one, but I know 1, 2, 3 things on this one. So this is the one I'm going to be using. Look at the way this is situated though. The things that I know are this one, this angle here, and this. I know the triplet. This is the cosine rule. Call this little a, call this capital A. All right. So a squared, right? It doesn't matter which is B and C. Copy this, equals B squared plus C squared plus, oh no, is it minus 2BC? One of the worst videos I've ever made this. Cos A, right? What a mess. So A squared equals, let's just quickly turn this in, right? So equals B squared. Could have put that in brackets. I tend to do that tonight. 8.1 squared minus 2 in brackets 10.6 close brackets, open brackets again, 8.1 close brackets, and then cos, and into there we're going to put 73 close brackets equals, okay, 127.76, and then I could probably give an extra decimal point there, 764, but whatever happens, I'm going to square root that to get A, right? I'll just take the full thing though. So 11.3, so A equals 11.3, that's that there. Lovely. Now we know, right, look at this. We now know a complete pair and an incomplete pair, and this is the one I'm trying to work out now, okay? So what will that look like? Okay, because this thing that we're missing is a side, it's side over sine 80, and then equals the complete pair. 11.3, which came from the answer, my answer there, divided by sine 54. So x equals 11.3 over sine 54. And the opposite of dividing by sine 80, which is what we're doing here, is to times sine 80, and we'll put that into our calculator. Oh, and I'll show you to do that just quickly. So you could use that here. Okay, 11.3, press down. At least we can see the calculator. I hope you can see the calculator now. Watch though. You can't just put times. You're going to have to close the bracket and press over so that we put the times there, not on the bottom of the fraction. Times sine 80. Chaps, that went a bit wrong as well because my video ended, but you were seeing me putting that sum into my calculator just now, right? I was just putting that in, and it gave me the answer 13.8. And we're in meters. I forgot to say we are in meters here, aren't we? Okay, so that's a nice one where we've got a bit of cosine rule and a bit of sine rule. Let's take a little look. If we got another example, it might be worth doing a couple of these. So here it says, show that the distance Sarah travels from the last marker back to the finish point is 7.7, just prove it, okay? Yeah, that's okay. Again, I don't really want to go into it, but there's my complete pair there, and there's my incomplete pair, and my task is to work out x, yeah? So very similar thing, right? I'll just set it up, x over sine 131, and then put the complete pair this side, which is the 5.4 over the sine 32. Take that up there as a times, stick it in your calculator. Yeah, cool, not bad. All right, what have we got here? Calculate the length of the single shot, okay? Now that's better. That's better. That's more like it, right? This is the kind of thing I was looking for, right? Just to show you. I can see the complete pair, right? But what the other thing that I see here is this. All that's going to allow me to work out is that angle there, which is the incomplete pair. So that is where I have to start. And if you notice, it's 7 marks. It must be more than one. When you look at a 7, there are about 3 or 4 marks each of these. If you look at 7, you're like, this is 2 things. Maybe 2 and an extra bit. 3 each and an extra 1. Well, let's have a look what that extra 1 is. So to begin with, I'm doing nothing. I'm doing what this allows me to do. Okay. But because I'm working at an angle, I'm going to put the angle on top. So I'm going to put sine, don't know, over the 160, right? There's my incomplete pair. So when you're working out missing angles, put the sine angles on top. If you're working out missing sides, put the missing side on top. It equals, and then my complete pair is sine 32 over 148. I like the fact we've got one of these to do. We said that the opposite of divide in there is to times by 160. So what we get is sine theta equals, I am doing this one. Right, what a long vid, yeah? So we got, let's go into here, sine 32. Again, I hope you can see this calculator. If you can't, I'm just typing in that sum, right? And you need to probably check on your own calculators to make sure that this works, right? 0.573 to 3 decimal places, right? But when we work, anytime we're working out missing angles, be it SOHCAHTOA or be it sine and cosine rule, we know we have to use that function. Let's have a look. So shift, sin minus 1. And I might just use the answer button again because it just puts that last answer in there for me, right? So actually it's more accurate if anything. So 34, look, it was 0.95. You wouldn't call that 34.9 because the 5 would round that up. So if we're rounded to 1 decimal place, that's going up to 35 degrees, right? So that angle there is 35 degrees. But it still doesn't help me with this. Let's go to a different color. This is what I've been asked to work out, the length of the single shot, right? This is something you've always got to bear in mind. As soon as you know 2 angles, you know 3 angles. So if you know that this is 32 and this is 35, then you can easily work this out. I'm going to have to draw this again and take the stuff that we need, okay? We still have the complete pair that we started with, but this is the side we wanted to work out, the single shot here. We were always needing this angle, really. However, because we know this is 35, if you add the 35 and the 32 and take that away from 180, take 67 away from 180, you get 113. That's that angle, and we're away to go. Now we're away to go. So in all these questions, bear in mind, if something allows you to work out 2 angles, you suddenly know 3 angles, right? So this time, x over, I flipped it. I'm now putting the angles on the bottom and the sides on the top, and my complete pair, again, it's a flip of what I did earlier. I'm putting the 148 on the top and the sine on the bottom. Take that up there as a times, and work out what x is there. Lovely. Glad that's there. We've now seen everything we need to, right? Seen everything we need to. And finally, for this little video, okay, then next video is going to be any missing bits that I can think of, plus AER, APR, and histograms. histogram's a big one that I just think we just haven't done enough on. Okay, so let's cover as many of these as we can. Earlier on, we started this video with length scale factors, or started part A with length scale factors, right? But at the end of the paper, you're going to get one with the 3 scale factors involved. Remember, if you need area, you square this. If you need volume, you cube this. If you need that one, you square root that. And if you need that one, you cube root that. This is a question of what can we work out, or what do we get given, but what do we need? Right? Look. The volume of the large toy plane is 6 times, that's the volume. Okay, in other words, I don't even have to work it out. What you have given me is you have given me the volume scale factor. You have told me that the big plane is 6 times bigger. You've then asked me to work out the length of the smaller plane. So the scale factor I need isn't that one, it's that one. So that's what I need to do to get there. Now, you could put that in your calculator, you could, and get an answer. Don't round it though, because it's not the final answer. Or you could just leave it like that and go, do you know what, I'll just for a minute, I'll put that into the next thing, okay? Then we're going to work out, okay, are we making that bigger or are we making it smaller? Well, we're making it smaller. So what we need to do is divide by the volume scale factor. Now in here, you can either put your answer to that, or you could just put that in like that. Okay, that's probably the most accurate. Although I do think a lot of you will have already gone, look, right, where is cube root here? Do we have a cube root button on here? There, it's in blue there. So shift, there you are, cube root of 6. So some of you may have worked that out, right? And written 1.817. Don't, right? However, we're going to go 30 divided by, and we can either put that in there or just use the answer to that, 16.5. Beautiful. To 1 decimal place. Love it. Let's keep going. Let's again play a game of what do we know, what do we need, right? Looks like we need the length scale factor already, doesn't it? Because we're trying to work out a missing height, and that's a height. So these are lengths. Great. The base area is 2.2. So they've given us what they've given. They haven't had to work it out. They've given us the area scale factor. But again, we want the length scale factor. So this time we're not cube rooting, we're square rooting that. Again, you could work that out and write the answer, or you could just leave it. Again, we're going to the smaller, so we're not timesing by our scale factor, we're dividing by our scale factor. I believe it's quite a nice sense of that one, right? So 12 divided by square root of 2.25, or you could have just put your scale factor, and that is 8. Fabulous. I just think we just keep going. Right. The volume of the small can, calculate the base. What the? The volume of the small can is 144. Right. Calculate the base area of the large can. Okay. Okay. There's actually a couple of ways we could do this. Right? And you might do this a different way to me, but here's one way we could do this. We've just worked out that this is 8, and we know the volume is 144, right? So, bearing in mind, right, the volume is the area of the base times the depth, or whatever. We've said this a few times. So, is the volume. If we know the volume is 144, and we know that the height is 8, if we divide that by 8, that's going to tell us the area of the bottom. Yeah? So this is just one way to do it. So if we go 144 divided by 8 equals 18. Lovely. So basically, what we've got is we've got an area here of 18, and when we times that by the height of 8, we've got 144, but it would like the area here, right? So one way we could do this is just to use this scale factor and go, okay, if I want the area, if it's the area scale factor I need, then I just need to times that by 2.25. So that's one way to do it. There are others. So the answer would have been 40.5. Beautiful. Centimeters squared, because it's area. Fab. Okay. We haven't had one yet where we've actually had to work out. Maybe now. Oh, I love it. Okay. Love this, because this is just perfect, right? Medium and large coupe, right? That is another word. Capacity is another word for volume. You can see it's in meters cubed. So by dividing these, that is my volume scale factor. Okay. However, this asks for an area. So the scale factor I want is that it is impossible to go from there direct to there. We have to go VSF back to LSF, then to. So even that's the one we've worked out, but because this is the one we need, we've got to go on a journey, right? So the length scale factor is the cubed root of the volume scale factor. Let's find cubed root again. I'm going to just put it in as a cubed root. I'm going to use the fraction. I'm just doing this 27 over 8. Okay, it's 3 over 2. I can actually write that, that's not a problem. And then the area scale factor is this squared. So I need to square that, which is 9 over 4. Fabulous. So the smaller one is an area of 3. Because I'm going to make it bigger, I'm timesing by my scale factor, but my area scale factor is 9 over 4. Okay, actually it works out. So times 3. And you can leave it like that, but if you want to do that, it's 6.75 at that point, just to give you final answer, 6.5 meters squared. I think that'll do for now, chaps. I don't think there's a lot long left in this video, is there? Oh, there's 2 minutes left if I need it. Come on. Oh, this is nice. Calculate the surface area. Don't worry that this surface is still an area, right? Yay, because this is length. So this would be length scale factor. Work it out, right? But I need the area scale factor. So it's my, whatever that is, whatever that length scale factor is, that squared. The total surface area on this one is 400 centimeters squared, and I'm trying to work out the total surface area on this one, so it'll be 400 times whatever we've worked that out to be. Okay, right, fab, right? I will mention here again length scale factor, but it doesn't talk about area, but it talks about the cost of paint is £1.60 for this one. Just bearing in mind, you're painting, in this case, an area, because it's a flat road sign, right? So it's the length scale factor you need, you work out, 45 over 30, but you need the area scale factor. I think that's 1.5. So you need 1.5 squared, right? And then it'll be £1.60, even though it's a cost, times your area scale factor. So even though it doesn't mention what's the area of the big one, it says what's the cost to paint it. Well, you're painting an area. End of video 3 will come very soon.